Look at the palm of your hand. It feels solid. It feels permanent. But in reality, you are looking at a collection of atoms that have been recycled through the hearts of dying stars for billions of years. Image, close-up macro shot of human skin texture transitioning into glowing star clusters. Most of what we call reality is actually a thin, fragile layer of stability floating on an ocean of absolute, chaotic nothingness. Image, a vast, empty void of space with tiny, distant flickering stars. We are accustomed to thinking of the universe as a container, a box where things happen. But space is not a container. Space is a dynamic, stretching fabric, and it is doing something right now that scientists are still struggling to fully explain. Image, computer-generated visualization of the fabric of spacetime stretching and warping. It is tearing itself apart. Image, a deep field view of galaxies drifting further away from each other. Everything you see, every planet, every star, every galaxy you have ever heard of, makes up less than 5% of the actual universe. The rest is invisible, untouchable, and seemingly impossible to detect. Image, a graphic showing a pie chart of the universe, 5% matter, 27% dark matter, 68% dark energy. Welcome to the edge of what we know. Today, we aren't just looking at the stars, we are looking at the architecture of existence itself. Image, a wide-angle shot of the Milky Way galaxy stretching across a night sky. To understand the universe, we have to look back. Not just thousands of years, but 13.8 billion years into the past. Image, an animation showing a singular, infinitely dense point of light expanding rapidly. At the moment of the Big Bang, the universe was not a giant explosion in space. It was the explosion of space itself. Image, high-resolution animation of the inflationary period of the early universe. There was no outside. There was no before. There was only the sudden, violent expansion of the physical laws we live by today. Image, abstract representation of early quantum fluctuations forming cosmic structures. In those first few fractions of a second, the universe was hotter than anything we can replicate in a laboratory. Image, a fiery, chaotic soup of elementary particles swirling in a void. As it expanded, it cooled. And as it cooled, the fundamental forces of nature began to separate, like oil and water. Image, artistic depiction of the four fundamental forces splitting from a single unified force. Gravity, electromagnetism, and the nuclear forces set the rules for the game. Image, close-up of glowing, geometric patterns representing physical laws. If gravity had been even a fraction of a percent stronger, the universe would have collapsed back in on itself in a matter of hours. Image, a star collapsing into a dense, dark point of gravity. If it had been weaker, stars never would have formed. We are living in the Goldilocks zone of cosmic evolution, a fragile balance of numbers that allows consciousness to exist. Image, a beautiful, vibrant nebula with star-forming regions glowing in pink and blue. But look further. Look at the way galaxies move. Image, telescopic footage of galaxies rotating in a dark, empty field. When we observe the rotation of galaxies, we see a problem. They spin too fast. Image, a diagram showing the discrepancy between observed and expected rotation speeds of galaxies. The outer edges are moving with such velocity that they should fly apart, shedding their stars into the dark void. Image, a conceptual art piece showing stars flying off a spinning spiral galaxy. Yet, they stay together. They are held by an invisible tether, dark matter. Image, an animation showing dark matter as a transparent web-like structure connecting galaxies. It is a ghost in the machine. It doesn't interact with light, it doesn't bounce off matter, and it doesn't emit radiation. Image, a dark, moody visualization of a hidden, massive gravitational well. We only know it's there because it bends the light of galaxies behind it. Image, gravitational lensing effect, light curving around an unseen object. It is the scaffolding upon which the universe is built. Without this invisible web, the beautiful, complex structures of our cosmic home would simply be dust. Image, a map of the cosmic web showing the distribution of dark matter across the universe. But dark matter is only the beginning of the mystery. Image, a silhouette of a human standing under a massive, starry sky. While gravity pulls matter together to form stars and galaxies, there is another force working in the shadows. Image, an ethereal, pulsing wave of light expanding outward through space. We call it dark energy, and it is the dominant force in the universe. Image, a conceptual visualization of spacetime expanding faster and faster. Think of dark energy as the opposite of gravity. While gravity tries to pull the universe into a cohesive, tight-knit group, dark energy is actively pushing it apart. Image, a split screen showing matter clustering on one side and space expanding on the other. For billions of years, gravity was winning. It brought matter together into galaxies. Image, an animation of two galaxies colliding and merging. But about 5 billion years ago, the density of matter thinned out enough for dark energy to take control. Image, a graph showing the acceleration of the expansion of the universe over time. Now, it is accelerating. The void between galaxies is growing. Image, an animation of galaxies drifting away from each other into the distance. The scary part? We have no idea what it is. Image, a question mark formed out of star particles floating in space. Some theorize it is the energy of the vacuum of space itself. Others think it is a property of spacetime that changes as the universe ages. Image, scientists working at a high-tech observatory with complex data visualizations. Regardless of its nature, the consequence is clear. The universe is heading toward a big freeze. Image, a cold, blue, desolate cosmic landscape with no stars. Eventually, galaxies will move so far apart that they will disappear from each other's horizons. Image, the night sky slowly losing its stars one by one until it is pitch black. The night sky will become a dark, empty canvas. Image, a single, lonely planet drifting in a completely dark, starless void. This is the midpoint of our story, and it's a perspective shift that challenges our very meaning. Image, a close-up shot of a human eye reflecting the stars. We have always looked for meaning in the grand scale of the universe, assuming that if the universe is infinite, our purpose must be as well. Image, an ancient observatory dome opening to the night sky. But if the universe is finite, if it has a beginning and a very cold, dark end, does that make our current existence less significant, or more? Image, a small, fragile-looking Earth floating in the vastness of space. To answer that, we have to talk about entropy. Image, an hourglass with sand running out, set against a background of space. Entropy is the law of disorder. It dictates that all things move from order to chaos. Image, an animation of a perfectly structured crystal shattering into fragments. A star is a pocket of order. It is a machine that burns fuel to create heat and light. Image, a sun-like star with solar flares and complex surface activity. But every second a star shines, it loses fuel. Every second, the universe edges closer to a state of equilibrium. Image, an image of a dead, white dwarf star fading out. When every star has burned out, when every black hole has evaporated into Hawking radiation, there will be nothing left but a cold, thin soup of photons and subatomic particles. Image, a final, fading light particle disappearing into total darkness. That is the final, ultimate heat death of the universe. Image, an abstract representation of the final, silent state of the cosmos. It sounds bleak. It sounds like the end of hope. Image, a deep, thoughtful close-up of a human face looking upward. But consider the timing. You are alive during the briefest, most vibrant epoch of the universe. Image, a high-contrast image of a nebula glowing in the darkness of space. The age of stars. The age of galaxies. The age of complexity. Image, a time-lapse of a flower blooming, signifying life and complexity. Before now, the universe was too hot and chaotic for complex molecules like DNA to form. Image, a microscopic view of complex organic molecules forming. After this era, the universe will be too cold and sparse for life to find the energy it needs to function. Image, an image of a desolate, frozen, planetary surface. We are living in the absolute peak of the universe's life. Image, a bustling, colorful montage of galaxies and nebulae. This realization brings us to a mind-blowing question: are we alone? Image, a radio telescope dish pointed toward a dense star field. If life is a natural byproduct of the laws of physics, then it should be happening everywhere. Image, an illustration of planets orbiting distant stars in the habitable zone. Yet, we see nothing. No radio signals. No massive engineering projects in other star systems. Image, a silent, radio-quiet desert landscape with an array of telescopes. This is the Fermi paradox. Image, a graphic showing the scale of the galaxy versus the signal we have searched. It implies either that we are the first, or that we are the last, or that we are simply too small to be noticed by the masters of the cosmos. Image, a lone astronaut walking on the surface of a moon, looking at Earth. Or perhaps, the distances are just too vast. Image, a light-year scale visualization showing the distance between stars. Light travels fast, but the universe is massive. Image, a beam of light crossing a massive distance between 2 points. Even if a signal was sent from the nearest star, it would take years to reach us. Image, a simulated incoming signal on a computer screen flickering to life. We are trapped in our own bubbles of causality, unable to reach out to the neighbors we suspect are there. Image, a silhouette of a person looking through a telescope lens. But think of what we have achieved in our tiny window of time. Image, footage of human space exploration, from Apollo missions to modern rockets. We have mapped the cosmic microwave background, the fading echo of the Big Bang. Image, a colorful, speckled image representing the cosmic microwave background radiation. We have measured the expansion of space. Image, a sophisticated instrument measuring light spectrums. We have looked back billions of years into the past with the James Webb Space Telescope. Image, a stunning, high-resolution photo of deep space galaxies from the JWST. We are, as Carl Sagan once said, a way for the universe to know itself. Image, a collage of human scientific achievements and space exploration photos. That is the climax of this story. We are not just inhabitants of this universe. We are its witnesses. Image, a wide shot of the Earth from deep space, emphasizing its solitude. Without observers like us, the universe is just a collection of particles and forces, unaware of its own beauty. Image, a glowing, ethereal view of a spiral galaxy. We give the universe meaning by assigning value to it. Image, a shot of a person sketching a star chart in a notebook. The silence of the void is not a sign of nothingness, it is a canvas. Image, a pristine, clear night sky filled with millions of stars. We may be small. We may be short-lived. We may be a statistical anomaly in a cold, dark, and expanding reality. Image, an astronaut looking out of a cupola window at the Earth below. But we are here. And for this brief, miraculous flicker of time, we get to look up and wonder why. Image, a close-up of a human eye, mirroring the stars inside the iris. The universe will continue to expand. The stars will continue to fade. Image, an abstract animation of a star slowly dimming and blinking out. But the fact that we have spent this time understanding the mechanisms of our own existence is an achievement that defies the entropy of the cosmos. Image, a beautiful, wide-angle shot of a horizon with a rising sun over an alien landscape. So, what does this mean for you? Image, a person sitting in a quiet, dark room, reflecting. It means that every moment you spend learning, exploring, and questioning is a victory against the dark. Image, a montage of science books, telescopes, and computer screens. It means that your curiosity is the most powerful tool in the universe. Image, an image of a brilliant supernova explosion, bright and energetic. The journey doesn't end when the credits roll. It continues every time you look up at the night sky and ask, what else is out there? Image, a long, slow zoom out from Earth to the entire observable universe. If you enjoyed this journey to the edges of space-time, consider subscribing to keep exploring the frontiers of human knowledge. Image, a clean, professional outro screen with channel branding. There is so much more to see, and the universe is waiting. Image, a final, lingering shot of a vibrant, colorful galaxy rotating slowly in the dark. Thanks for watching.